To address interference in two dimensions, we simply have to keep track, as before, and actually it might be, conceptually at least, a little bit easier in two dimensions because we're going to make it very clear that what we're looking at is I call that thing 1, and that distance 1, and this is thing 2, and that is distance 2. Then, again, interference happens. I've got, let's see, d2 minus d1. Not di, d1. One of the three things will be true. If d2 minus d1 is equal to some integral number of wavelengths, as long as both of these, again, have, if we're looking at, two waves, let's even say two identical waves. We could use this with two different waves, and we would still be looking at these cases. Add to that, but we'd be looking in terms of phase. We're not going to get quite that involved in this class. This will be enough fun. So if I've got two identical waves, each transmitting at different points, then if I'm looking at them at different points in space, it just falls back to, like before, a question of the differences in paths between the two. If the path difference between those two waves is equal to some integral number of wavelengths, then they're going to be in phase, and the two waves will constructively interfere. If the difference between them is equal to some integer, 0, 1, 2, 3, 4, whatever, then they'll be completely destructive, and they will not interact with each other. Now, anything else will be destructive to some other level. Most of the problems we're going to deal with will be very simply either setting up a way for these paths, checking these paths, oh, how do they match up? Or looking at things that exist and saying, okay, what are the differences between these two? So if I have looking at some point, let's say this is x, heck, let's just call that point capital X, and that point capital Y, then the distance from the speaker to X is just equal to that distance in the X direction. But, oh, let me just say, call that point P. The distance from the second speaker to point P will be, well, the hypotenuse of that triangle. So the square root of x squared plus y squared. So the question will then become, for these, how, for those cases, is there anything special about the distance square root of x squared plus y squared minus X. But if you address it in this way, that will almost always be eminently suitable.